All right, everybody. Well, welcome to this section on time value of money. I'm going to do this presentation just a little bit different because I want us to be able to see exactly how we would look at this using a financial calculator. Um, you'll have access to the PowerPoint deck as a PDF. There's a lot of practice problems in that PDF, which hopefully you've had a chance to review. So I'm not going to go through great details going through and outlining all of that content. The examples are there. If you have any questions, obviously send me an email, but you can see exactly how to enter those. But I want to give us just some time to go through I'm just going to go through some basic examples. And as you can see on the screen, we're going to have the opportunity to see how we would enter this on a financial calculator. So as you see on the right side of your screen, the financial calculator, I use the BA2 Plus from Texas Instruments. It looks like this. Okay, so I would encourage you, if you're going to do anything in business or anything in finance, I would encourage you to have one of those. They're not very expensive. You can typically get them on Amazon for maybe $20 or $25. But it's great if you're ever looking at doing a quick time value of money calculation, and we'll talk about different ways that might look for you. If you're getting a mortgage, you might be able to see, okay, what would my principal balance be after, let's say, 3 years in the house, making these payments? You could see what you would owe on the house. So there's a lot of neat things that you would do, even if you aren't a finance major or if you're not wanting to go into finance. Again, it's a very simple calculator. If you don't want to use a financial calculator, there are plenty of apps that you can download for your phone or an iPad. There are also websites where you can put in the variables and it will give you the information that you need in terms of time value of money. So there are time value of money calculators online, websites, apps, calculator. But it will need to be designated as a finance calculator, because what you're wanting is you are wanting this row of data right here, which is this gray set of boxes: NIY, PV, payment, PMT, and FV. So we're looking for, let me change colors here so we can see. So we're looking for this row right here. Okay, so that's what we'd like to have for our calculator. Okay, all right, so just let me reiterate, we are not going to be going through the deck like I did in the two previous sections. This one, I really want to just kind of focus on looking at how we're going to use time value of money, make sure we understand how to enter it in the calculator. And as you can see in the top right-hand corner, there's a blank black box. This is actually going to show us the tape. So as I enter information in the calculator, if for some reason you miss it, you can look up at the tape and you'll be able to see what exactly I entered. And I'll show you that here in a moment. So let's go ahead and, without further ado, we'll go ahead and get started. Okay, so what is time value of money? Well, it really is, if you just think about this idea of a timeline, okay, this timeline is typically will start with something like, well, here's today, and I'm going to move out into the future, okay, sometime in the future. So let's just say this was 10 years from now. So we've got 2034, okay? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, okay? All time value of money is doing is it's moving money across this timeline, both forward and backwards, and it's providing us an equivalent value. So if I know what something is valued today, and I want to know how it might be valued, let's say right here, I could tell you what that value is if I have certain inputs, certain assumptions about what is going to happen. Okay. So we want just to make sure that we understand what exactly is time value of money and why it's so valuable, because we can take money today, move it out into the future, but really more specifically is we can take future money and bring it back to today. What do I need today in order to accomplish some future goal. Okay. So, what are some areas that this might help us with? Well, retirement would be a huge one. Okay. I know that I'm going to need some amount of money in the future. How much do I need to put in today? Okay. What about this idea of investing for a purpose? And what I mean by that is it could be a down payment on a car, on a house, could be a vacation home. I want to know how much I'm going to have if I invest X amount of dollars today and I can get some rate of return. Um, we might also figure out um, how much do I need to put aside. Okay, this is very similar to the retirement question. The retirement perspective, though, can be looked at two different ways. If I put in X amount of dollars, how much will I have? And then the other question is I want to have a specific amount of money in my account at a specific time period, and therefore I am going to move that back. Let me just pause the recording here momentarily. Okay, sorry about that. My phone was ringing. Okay. All right. So that gives us the baseline of what time value of money is. So what we want to make sure we do is, and there is formulas for each one of the time value of money problems. Um, I don't really think we need to get into the formulas. I want us to be able to make sure we understand how to do this on a calculator. Okay. Now, a couple of things that we need to make sure we understand. Okay. One is as we move into the future from today, we compound our money. Okay. And these are just terms that we want to make sure that when you're looking at a problem and it says you're going to compound by, that means that the money is going to be compounding. You're moving the money out into the future. If we are starting out in the future and we are going to bring that money back, we will be discounting. Okay. So we're going to be discounting values. Let's say it's $100 in the future, and I want to know what it's going to be today. Okay. So I'm going to be discounting that amount. Okay. Okay. So there are going to be five main inputs that we will be looking at, and we don't necessarily have to have all five. Okay. But we want to make sure we understand what those five are, and they are on our calculator. The first one is N. This stands for the number of periods the money will compound or be discounted. Okay. So it's going to be the number of periods that there will be some form of compound. So let me give you an example. If we look at something on an annual basis, so on an annual basis, our N will equal 1. Okay. If we compound on a biannual basis, we will have 2 times the number of years times the number of years that we will compound. Okay. If we do this semi-annually, we will have, oh, that's the same thing. Sorry about that. Let's rephrase this. Quarterly will be 4 times the number of years. And if we do it monthly, we will have 12 times the number of years. Okay. Okay. We'll get into that. We'll look at some problems shortly. Okay. So that's N. All right. The next thing we need to make sure that we understand is our IY. This is the interest rate on an annual basis. Okay. Now, if we compound more frequently than annually, we are going to have to adjust this number. Okay. So when you receive a problem and it says you're going to receive 5% as your interest rate. That 5% is given into you on an annual basis. In fact, most all rates are given to you on an annual basis. Okay. So when we know what our interest rate is, if we're going to compound more than annually, we need to divide the interest rate by the number of compounding periods. Okay. So let me just give you one example. If we are going to have quarterly compounding, we will take our IY that is stated and divide that by 4. So we're going to take our IY and divide it by 4. And this is what we would enter into our calculator. Okay. All right. Next, we have PV. PV stands for the present value. Okay. What is the value today? And that's either something that we're trying to solve for or it's something that we know. But PV on the calculator stands for present value. Payment is what will we receive or what will we pay each period that we're making a payment. And in some cases, we may not be looking at trying to solve for payment. So not all of these are going to be necessary. It depends on what we're looking for. And finally, we have FV, which stands for what is the future value. Okay, so the future value. Now, another couple of things from the deck, again, that you'll see is when you have cash coming into you, okay, cash inflow, this is a positive entry into the calculator. When you have a cash outflow, this is a negative number into the calculator. Okay, so that's very important to make sure we understand what's happening with the cash flows. Now, here's what I want to make sure you understand. When you put a money into an investment, okay, so let's say you're going to figure out, I'm going to put money into my savings account for a specific investment goal. When the money, you might be thinking about, okay, well, the money's not leaving me, so it's not an outflow. Well, it kind of is in terms of our time value of money problems. Think of the money that is going to be in your pocket. Okay, that's where the money starts. If the money leaves your pocket and goes to your investment account or goes to somewhere else, that would be an outflow. So you would have a negative entry into that cash flow. Let's suppose you're trying to figure out something and it requires a cash flow into you. You want to know how much you're going to receive in retirement. Well, the money would be coming into your pocket from that investment, and therefore it would be a cash inflow. Okay. So we need to make sure we understand these concepts. All right. The other thing we need to consider is the timing of the cash flow. Okay. So we have our 5 components. We have the number of years, the interest rate, the present value, the payment, and the future value. Let me just go ahead and put those on here. Okay. So here's our 5. Okay. We need to make sure we understand those 5. We need to make sure we understand the plus and the minus sign, okay, or the positive and the negative cash flows. Now we need to make sure we understand the timing of cash flows. In a normal time value of money problem, the payment is at the end of the period. Okay. Now, if you look at my calculator, right under the word done, you see where it says END, end. What that means is that the calculator is telling you that at the end of the period is when there will be a compounding issuance, okay? Or some transaction is going to happen at the end of each period, okay? However, there may be times where we have to go at the beginning. Okay, let me give an example. When we're doing retirement calculations, we may need to know how much we need in retirement, but that retirement payment needs to come at the beginning of the month, not at the end of the month. Why? Well, we have all of our bills to pay in the month. Okay. And the reason this is important is because as our calculator is doing the calculations, it no longer can compound that first payment. That first payment doesn't get to generate additional interest or growth because we're getting that money today. That money is coming into our pocket today, which means it's not going to yield any return. So the calculation has to know, is the payment coming at the beginning of the period or the end of the period? Okay. So we need to know our five components. We need to know if it's a cash inflow or a cash outflow, and we need to know whether it's the beginning or the end of the period. Okay. All right. So we're going to do just a few basic um, problems. And now I'm going to go ahead and jump into making sure we can look at it from the calculator's standpoint. Okay. All right. So the first basic one is, let's suppose we have $1,000 today, and we want to know what this value is. So what's the value in 30 years if I can receive 6% interest annually. All right. So let's see what we can go ahead and just quickly do on our on the screen here, and then we'll put all of our inputs into the calculator. So the first is, what do I know? Well, the first thing that I know, and let's use we'll use blue, is I have a present value of $1,000. Now, before we get into anything further, what's happening with that $1,000? Is this going to be a positive or a cash inflow or a cash outflow? Well, I have $1,000 in my pocket, and I want to invest that, and so the money is leaving me. Okay, so what's happening? Is that an inflow or an outflow? That is going to be an outflow. So that's going to be a negative $1,000. This is a cash outflow. Okay. Okay. Let's look at the next one. What is my interest rate? Well, I said 6%. So it's going to be 6%. Now we're going to enter as a whole number. So we're going to enter this as 6. The calculator will automatically turn that into a percentage. Okay, so you don't have to type in 0.06. It is important that you know that the interest rate will be calculated as a whole number. Okay, so what's next on our calculator? N. What is our N? Well, we are compounding. It looks like annually. We are compounding annually, and we are compounding for 30 years. So we have 30 years. Okay. All right. Payment. Do we have any payments on this problem? We do not. So the payment here is going to be 0. Now, we don't have to actually enter 0 as a payment. If there is nothing entered, the calculator will automatically assume a 0 will fit there. Okay. And then what are we trying to solve? Well, we're trying to solve for this value. Okay. So this is what we're looking for. So we're going to hit then compute our future value for it to determine what it is. All right. So let's go ahead and do that. The first is, I'm going to go from left to right. So we have 30 as our N. And as you look up here on the screen, you will see 30 with N. N meaning the number of periods. Okay. So we've got that one. The next is IY. We have 6%. 6 IY. Okay. So we've entered IY. Next is present value. 1,000 minus present value. Okay. And as you can see, I have my calculator set to 4 decimal places. I believe that is going to be ideal for you. So you'll want to set your calculator, and the PDF gives you instructions on how to do that. Okay. So make sure you want to set that to 4 decimal places. Okay. All right. So we now have our present value. I'm going to go ahead and just enter 0 for my payment, just so that you know that you don't have to do that, but just so it's there. Okay. So I've entered payment. Now from here, I'm going to hit CPT on my calculator, which is right there. And I'm going to compute my future value. Compute future value. Okay. And you notice that I get an answer of $5,000 $5,743.49. As you can see, it is also a positive number, which means the investment is coming back to me as a positive cash flow to me. Okay, the money's coming back to me. So this is good. I gave $1,000. It invested at 6% for 30 years. And then now, after 30 years, I'm receiving $5,743.49. Okay. All right. Are we okay with that? Now, let's make a quick adjustment. I'm going to change colors just so that we can see what will happen here. Let's suppose that we don't have 6%, but we get compounding quarterly. Okay. So what does this mean? Well, this means that I'm receiving 4 payments per year. Okay. Now, we're going to make some adjustments on our numbers, and then I'll go back into the calculator and readjust those numbers. Okay. All right. So does the present value, does this number change any, knowing that we are going to have compounding quarterly? It does not, right? We have our original $1,000 that we're going to invest. The compounding frequency does not matter with our present value. Does it matter with our payment? Well, it would if we had a payment, but we're not worried about that right now. Okay. Our interest rate. This interest rate was given to us on an annual basis. So if you recall back on the previous slide, what did we have to do? Quarterly. We have to divide our payment, our interest rate by 4. So we're going to take our 6 and we're going to divide it by 4. So let's do that on our calculator. So we have 6 divided by 4, and that is 1.5. This now is our new interest rate. Okay. So 1.5. So we are basically going to earn 1.5% each quarter. All right. That's what that means. Now, we have 30 years, but we now need to adjust this number of years because we are compounding quarterly. So this, if you go back and look, our number of periods quarterly, we are going to multiply that by 4. So we're going to multiply this by 4, and our new number of periods will be 120. Now, we are still going to be evaluating this over 30 years, but now we have 120 compound periods. Okay, so we have 120 compound periods. So now we have 1, 2, 0, n. Okay, so as you can see, I have adjusted the interest rate and I've adjusted the compound periods. And also, if you look at the top of each of my numbers, so n, it shows 120. So I'm looking at right here. You see n is 120, IY is 1.5, my $1,000 outflow, and my payment is still 0. Okay, now if I hit in yellow, compute future value, it now goes to 5,969.32. All right. What happened? I didn't change how much I invested. I didn't change the number of years that I wanted to invest, but my value actually went up by $226. Well, because we've increased the frequency amount of our compounding, the interest that we earned in the first quarter is now included in our principal. And that interest is now included in the second quarter. And then it just keeps compounding. So over a 30-year period, by compounding 4 times a year versus just once a year, we actually generated an additional $223 and some change. Okay. So compounding frequency can be extremely valuable for you. And it's the longer we have to compound at the more frequent intervals, the higher these numbers get. So that's why it's so important to start saving early as you possibly can, into accounts that you're going to allow to grow, and to have those compounding periods as frequently as you possibly can get, whether that's monthly, or semi-annually. Obviously, if annually is an option, that still may be the right choice. But we want to be able to have investments that yield us a more frequent compounding, and where we have more time, because as we increase time, the number of compounding periods will continue to increase. Okay. All right. So that's just a basic premise of what we're trying to look at for going into the future. Now let's go ahead and do a new slide and let's look at what is it like to have money coming back. So we know that we want $1 million for retirement. And let's say you are 20 years old, and you want this at the age of 65. Okay. So 65 years old is when you want this, and you are 20 years old today, which means we are going to invest for 45 years. Okay. All right. So we have 45 years of investment. And we want to know how much we have to save. So we want to know how much do we need to save to reach this goal if we can earn 8% per year compound monthly. And why we want to do this monthly? Well, most people, get paid at least on a monthly basis. And so we want to know, how much do I have to set aside each month in order to reach this goal? Okay. So let's figure out what we have. And let's just we're going to follow our number line, or our calculator over here. So we'll always start with n, just to go from left to right. All right. First of all, let me clear everything here, just so we don't miss anything. Okay, all my numbers should be 0 across the top of my time value of money function buttons, which they are. And how many years do we have? Well, we have 45 years, but we're going to be looking at this on a monthly basis. So how many months is this going to work? Well, we have 12 months in each year. Okay, so I'm going to get my calculator and we're going to go 45 times 12. So we have 540 compound periods. Okay. Okay. The next one is our interest rate. Okay. We know that we can receive 8% per year, but we're going to compound monthly. So we need to divide this by 12. Okay. So 8%, remember, we don't put it in percentage decimal form. We're going to put it in as 8. We're going to divide it by 12, and we're going to get 0.6667. This is our interest rate per period. Okay. All right. Our next is our present value. Well, do we have any money today? Well, let's say you don't. Let's say your present value is 0. You're starting with nothing, and you want to know how much you are going to need to do each month. So our present value is going to be 0. That's okay. All right. Next, payment. Well, isn't that what we're trying to solve for? We're trying to solve for payment. We want to know how much we need to set aside each month. So we actually don't know this answer yet. And then finally, future value. Do we know what the future value is going to be? Well, we know what we're trying to solve for, which is $1 million. Now, is this $1 million an inflow or an outflow? Remember, the money is going to be coming back to us. We want that $1 million to be in our pocket at the end of the 45 years. So this will be a positive number. Let's think about this. What would we expect the payment to be? The payment should be a negative number, a cash outflow. Why? Well, because remember, we're putting that money aside into this investment each month. So the money is leaving our pocket and going into the investment. Okay, so we should expect a negative number. All right. Okay, so now that we have all of our inputs, let's go ahead and put in them in our calculator. Now I'm going to clear the tape just so we have a fresh start. And I'm going to go ahead and clear everything out just to, again, make sure I'm hitting second clear time value of money. Okay. All right. So number N, we have 540 periods N, 540. Our interest rate, and I'm going to just go ahead and do this for you. I'm going to do 8 divided by 12. This is our monthly interest rate, and I'm going to set that as my interest rate. And as you can see, it rounded to 0.667. Okay. On the button itself, it shows 0.67. That's fine. Our present value, let's just go ahead and enter 0 because we don't have any money set aside. We are trying to solve our payment, so we want to wait on that one, and we want $1 million in as a future positive cash flow. Remember, we want this money to come back to us. Okay. And as usual, I will hit compute and payment. Now look at that. As a 20-year-old for 45 years, you would have to put aside $189.59 per month. And at the age of 65, you will have $1 million. Is that a lot to you? Well, for some people, that may say, no. I mean, if I make $500 a month, I could easily do that. Now, there's a couple of things that we need to make sure we're aware of. These problems are assuming that you are going to earn 8% per year, or 1.5% or I should say 0.667% per month on a linear fashion between now and the next 45 years. That is not going to be possible. There's no way that we will see a straight lined interest rate unless you were able to lock in 8% per year, compounded monthly, for an investment for the next 45 years. And there's just not anything out there like that. Okay. So this is going to, you have several assumptions that you have to make. Okay. You have to make assumptions based on is 8% the right number to move forward with? Maybe that's too aggressive. Remember, you have to look at this as a 45-year investment. The other thing is we have to do, and this is where financial advisors really add a lot of value, is they will actually do this, and every year they will update their models with their clients. And what are they able to update with? Well, if you recall, every year as we move into investments, I might actually now start my next year with money set aside. Let's suppose we're 1 year into this. Well, we might have, and let's just round this up to 200. We might have $2,400 in our account that we are starting with. And then, of course, this moves to 44 years times 12, and everything remains the same. And then our new payment would actually change. Okay. But we're starting with a different amount. And the reason we're going to change is because the interest rate may be changing. As the economy expands and is moving into a growth phase, we might be able to say maybe 10% for the next 2 or 3 years. As the economies begins to contract or restrict and we move into maybe a recessionary period, maybe 3 or 4% is all we should be expected. So the interest rates will change over time. Okay, so in a nutshell, I wanted just to provide you a way to be able to understand how to use the financial calculator. And I wanted to give you several different calculations from both moving the money from today to the future, as well as understanding what the future looks like and bringing it back. And I try to keep things very simple using our financial calculator. We didn't look at any formulas. We didn't go into great detail, but this is how you would solve those problems, looking at those 5 main inputs, making sure your cash flows are positive or negative, depending on if it's an inflow or an outflow. And the one thing that we didn't do, which is fairly straightforward, is just if you know that you're going to need the payments at the beginning of the period, then we would want to make sure we set our calculator to the beginning of the period and everything else remains the same. And we would do that by hitting second, enter, second, payment, second, enter, set, and that turns it to begin. And you should see when you clear everything out that the top of my calculator now says BGN. Okay. Again, that information is in the PowerPoints for this lesson. So hopefully this was valuable. Hopefully you can see how these problems are worked. And now as you go through the PDF or the PowerPoints, you will see exactly how to work these using your financial calculator. All right, everybody. I hope this was helpful. If you have any questions, let me know.